Hey, hi folks. Hi folks. Good afternoon. How is everybody doing? Hi Darshan. Hi Mushkin. Hi Utkarsh. Hi Jitin. Okay. Hi Sunil. How we will get certificate? Uh, Actually, we will be floating a link at the end of the session. So that's how you will get the certificate, Kishore. Hey, hi Tushar. Hi Harinath. Hi Jasmine. Hi. Good to see you all folks. Joining, and I hope you will learn a great deal of knowledge about SQL today. And hopefully, this session would be beneficial for you in terms of uh, understanding what SQL is and voice breaking. Is everybody able to hear me properly? Somebody is mentioning the voice is breaking. You're audible. Okay, thanks. All right. So first, let me give you guys an overview of what we will be learning today, and then we will go ahead and discuss uh, each topic in finer detail. Okay. So today we will be learning about what SQL is. What is SQL? Why do we need to learn SQL? And then we will see some common operations that we can do in SQL. So these will include creating the tables, updating the tables, dropping the table, and similar operations like that. Then we will go ahead and discuss some intermediate topics like we will discuss some intermediate topics like aggregation functions, joins. So these are some intermediate to advanced topics that we will be going to discuss, which includes aggregation, aggregation, and joins. Okay. And we will also be discussing some topics like primary keys and so we will also be discussing about some topics like primary keys and foreign keys and don't worry about it if you don't understand it, like what is a primary key and what is a foreign key. We will go ahead and discuss further what each of them means, and finally we will discuss about what are nexus and the importance to create indices. So these are some. This is a high level agenda of what we will be discussing today, and how we will be proceeding further into the session. Okay. So is everybody clear with the agenda? Uh, I still see people joining. Okay. All right. When we will be getting certificate, you will get this at the end of the session when you there will be a link floated and you have to just fill that form, share your details, and your uh, certificate will be sent to your respective mail IDs. So don't worry about it. The link will be floated at the end of the session. Okay. All right. So first things first, what is SQL? Okay. So SQL stands for structured query language. So as the name says, let's break it down. Let's break down the name. Okay, so the first thing is it is structured, then there is a query, and there is a language. Okay, so it is a language to do the query, to do, to search something, to insert something, to ask a query, right? And it is structured, so there are some set of rules that this language follows to perform a query. Okay, so that is what SQL means. Okay. But what is the purpose of learning SQL? Why are we learning a new language? So you must have learned some programming languages like Java, C++, Python, R, MATLAB, etc., etc., right? So every language serves a particular purpose, right? So suppose if I'm learning Java, I have a purpose to write my code in Java so that I can tell the computer that I have to do this set of instructions, I have to perform this set of instructions, and talk to the computer by writing my code in Java, which is then converted into binary format that the computer understands, right? So SQL is also a type of a language in which I can talk to the computer to get some set of tasks done. Okay. But this is different from the programming languages that we may have learned, like C++ and Java, because the use case of learning is different. Because SQL is associated with databases. Okay. So the primary use case where we need SQL is when we are storing the data somewhere. Okay. So suppose you are a client or an end user who makes a request, that I need to get some information. Okay. So suppose you log in to some website, you ask that, uh, suppose you log in on Zerodha or some uh, stockbroking application. Okay, and that you ask that find top 10 shares that are trading today, this is the query, this is the request that you make to the particular website or the application. Okay, now this request that you have shared, this goes to the server, which, and one more thing I would like to tell you, there is in between an API. An API is a tool that connects the client and the server. Okay, so the request that you make goes via an API and gets called to the server. Now server will accept this information that the user has asked to find the top 10 shares, okay, that are trading today. Now the server must have stored this information somewhere, right? So suppose you there are like hundreds and thousands of tickers or these companies that are actively trading. So those information is stored somewhere. Okay, so that place where information is stored is called a database. So database is the place where the information is stored. So database is the information where the information Uh, am I audible again? Sorry for the network interruption. Is everybody able to see me now and hear me as well? Audible and visible. Awesome. Sorry for the glitch. So, yeah, thank you for confirming, folks. So, I was saying that the end user makes a request. Uh, Stuck. Okay. Waiting for another minute for everybody to join back. Okay. So as I was mentioning that why are we learning a new language? Why are we learning SQL? Because if we understand that why are we learning something new, that will help us to get the context of what is the importance of it and what problem does it solve, right? So the end user is going to make a request to find the top 10 shares that are trading today. And that request goes to the server, which is responsible for providing the information back to the user via an API. Okay. So the server is getting the information from where it has stored the data. The data is being stored on a physical uh, machine. Okay, so the information is stored somewhere, and that is called the database. The database is the place where it is actually stored on a hard disk or something. Okay, so database is the place where the information is actually stored, and from database the server reads the information, retransmits the information back to the client. Okay, so that's how the whole life cycle of a request to response work. So server queries the database and prepares a response. Let me write down it as well. Server queries the database, and so I will be using DB for databases. So server queries the database and then transmits the response back to the client. Okay, so this how does the server query the database is the way how SQL works. So SQL is the mechanism how server is going to fetch the information from database, prepare a response, and send it back to the user. So that is why we are learning SQL, and this is very important in your day-to-day work when you will have to query the information. So like if you are working for a stock broking firm or a stock broking application, these are like some of the very like day-to-day queries that you will be preparing or that you will be working on, and optimizing such queries will be your day-to-day task. So that is the purpose of SQL. Okay, so SQL is a querying language that queries the records in a database and returns it back to the server, which prepares the response out of it and gives it back to the end user, which you see on your screen. Okay, so this is what SQL is, and the SQL. So SQL is a querying language, and it is used on the data that is organized in form of tables. Okay. Now, what a table is? Okay. Let me help you understand what a table is. I mentioned that SQL is a language that is used to query the data, but it is querying what? It is querying some relational database management system. Let me first write down what is the full form of RDBMS. It is Relational Database Management System. So relational means that there is some relation among the data that is stored. Okay. So there is some relation that exists between how the data is managed, and that data is managed in form of tables. So a table, how does a table look like? Let me show you how does a table look like. So suppose this is a table of 4 rows and 4 columns. Okay. So a table would look something like this. There will be a name of the table. There will be the name of the table. Let's say the table name is student. Okay. So student table has all the information related to the student. Okay. That's how the tables are structured. So if I have a table called student, it will have some columns which will contain all the information pertaining to or related to a student. So information like every student could have a student ID, a student could have a name, student could have a roll number, and say phone. Okay. There can be more columns added as well, so it's like address or things like that. However, for the sake of understanding, I am taking just 4 columns. Okay, I'm taking just 4 columns here. There is no restriction on the number of columns that you can add. You can have any number of columns in a table. Okay, and the name of the table represents that what kind of information this table is storing. Okay, and there can be multiple tables in a database. Like it is not necessary that there could be only one table. There can be multiple tables as well, like 5, 10, 100, any number of tables. Okay, so data is stored like, say, student ID is 1, 2, 3, name is, say, Pulkit, Alex, something. Let's take somebody from the audience. Kirti is there. Kirti. Okay. So there can be any name assigned to the student. Then can the roll number could be, say, 10, 11, 12, anything. Any integer could be there. And phone number, say, 1, 2, 3, 4, 5, 6, something, something. Okay. So this is how the data is structured in a database. Okay. So this is how a relational database works. Relational database stores the information in form of tables, where each table has a name and some columns attached to it. And each row represents the information for a particular user. So this first row, the row that I have highlighted, this contains the information corresponding to the student Pulkit. This row contains information corresponding to the student Alex. Okay, and this row contains information for Kirti. Okay, so this is what a relational database management system means, and we will fetch the information from such tables, from tables like this, using SQL or structured query language. Till now, is it? Are there any doubts? I am uh, like, if there are any doubts, you can ask that in the chat section. I am monitoring the chat to see if there are any doubts. Got it. Make the quality high. It shows you clearly. Okay, no, clear. Awesome. All right. So clear. Great. Awesome. Can we store data other than table? No. In relational databases, we store data in the form of tables only. Okay. All clear. Very good. Great. Awesome. Difference between database and relational database. So there can be, like, there are different types of databases also. Like the one that we are learning today is relational database, which I mentioned in form of tables. There are another ways of representing data as well, like NoSQL, but that is not the scope of today's discussion. Okay. So can we get the notes of this topic? Yeah, I can share that after the class. So repeat, what is RDBMS? RDBMS is nothing but relational database management system. So when I say relational database management system, there is some relation among the tables. Okay, as I mentioned, like there can be other tables also, and one table can have a relation with the other tables. Okay, and one relation within the table is that each row represents the data for a particular unique user. Okay. All right. Moving forward, uh, so why learn SQL? One thing we learned that if we want to get the data from a server, uh, the server wants to get the data from a database, then and it is stored in the form of tables, then we should definitely learn SQL. And another thing is that SQL, like if you learn SQL, this is a very in demand uh, skill that you possess, and this is like widely uh, used language to query the database. So this is our motivation to learn about SQL. Okay. So moving forward, this is just a graph that shows the skills that data scientists need today. So this is just a small motivation that why should you should learn SQL, if that helps. That there were 300 job listings from top tech companies, and these were the skills that was required. If you see SQL, 231 jobs require out of 300 required SQL in the job description. So I think this is good enough data to show that SQL is a very in demand skill that you should possess. Okay. Now, there are multiple SQL database management systems. Okay. What do I mean by that is that SQL has the common structure in the sense that the way we are selecting the data, the way we are aggregating the data, is more or less same. However, the syntax among different database management systems could be different. Okay. So if I have to give an analogy, that could be like you can create like array is a data structure that you can create in Java also, C++ also, Python also, right? But the syntax is different in every language, right? The way you create array in Java could be different from how you create an array in Python or how you can create an array in C++, right? Similarly, there are different flavors of SQL also. So there is MySQL, there is Postgres, there is MS SQL Server. So this is maintained by Microsoft. This is these are two different other versions. So the syntax could be different in MySQL to MS SQL to Postgres to Oracle also. So there is Oracle is another player which provides SQL capability. So there can be different flavors of database management systems. However, the ideal knowledge or the fundamentals remain same across. So if you now one question that might be coming to everybody's mind is should we learn MySQL or Postgres or MS SQL? So you do not have to ideally learn any particular database management system. You have to learn the fundamental concepts of SQL and understand any one of them, say MySQL, for example. And if you like the organization that you are working on is using Postgres or using MS SQL, basic syntax difference could be there. Okay, so a small basic syntax difference could be there, and that you can easily Google. Okay, that you can Google up like what is the this keyword called in MS SQL or what this keyword is called in Postgres. Okay, and as a senior developer, like I have spent about nearly 6 years working in the IT industry, so it is totally okay to Google syntax. So it is okay to forget syntax and Google it. So don't worry about it that you have to learn each and every flavor of this database management system. The core fundamentals should be clear to you. Okay. All right. Moving on. So for the current scenario, we are assuming a small data set, and we will apply the SQL querying syntax on all those on that particular data set. Okay. So to begin with, I will tell you how a table is created, how we can insert the information in a table, and then we will begin with these basics, how we can query the information. Okay, so the first part that we will go ahead with, create a table first. Create a table, because if we do not have a table, what we will query, right? First we will have to create one table. Okay, then second thing is insert some data into the table. Okay, insert some data into the table, and after creating and inserting the data into the table, then we will move ahead with how to query. Okay, then we will move ahead with how to query. And how to query is a bigger part, because there can be different types of questions, there can be different type of queries, right? So there can be different types of queries that you want to ask, like you want to ask like top 10 records, or you want to find the top 10 values, or you can find the values where the data is like this or that, or you want to order the data in some particular way. So the query types could be different, and for each type of query we will see how we can use this particular syntax to get the answer for those queries. Okay, so first things first, let's do the first two steps: create the table and insert the data inside the table. Okay, so this is nothing but a online compiler that just like runs the queries on the go. So you do not have to install anything on your system. This is an online compiler where you can just run your queries. Okay. Here you can even select any programming languages that you want. For our case, we do not need Java or something. We are using MySQL here to run our queries. Okay, and you have to just click this run button to see the output here. Okay, all right. So as I mentioned that first we are going to create a table. So the syntax to create a table is pretty simple. Okay, you have to write the word create and table. So create table tells SQL that the create table tells the user that user is trying to create one table. Okay, and here you have to give the table name. Okay, here you have to give the table name, whatever name you want to give to the table. Okay, in our case we have given the table name as employee. In this table we are storing the information for various employees that are working in a particular organization. Okay, so the syntax is create table, the name of the table, followed by the columns that we require in the table. Okay, so as I mentioned, if you remember from our previous discussion, we will have a table with the name of the table, and the table will contain some columns. Okay, so that is what we are doing. So we have created the table, create table employee. Okay, so we have created a table employee, and now we are trying to add some columns to it. Okay, so one column here is employee ID, the ID of the employee. Then we have the name, the which stores the name of the employee, and this is the department where, in which particular department the employee is working. So the department would be sales, marketing, IT, uh, customer service, and uh, something else. So these columns represents what kind of information of employee we want to store. Okay, again there is no limit on which the number of columns you can create. You can create any number of columns inside a particular table. However, it is recommended that your table should not be too large or too small. Okay, you should not create a table say with thousands of columns, because if you do that, it will be difficult to manage that table. Okay, so the process is called normalization and denormalization. However, that is beyond the scope of discussion for today's session. So the general thumb of rule is that you should create a table with decent uh, information, like that. When I say decent, there is no particular number like 50 or 100. It means that the table should contain all the information related to that entity, but it should not be too large or too small. Okay, so that is the only thing. Now we defined the columns and the table name. We need one more thing to define. That is, what type of data this column will contain. So the employee ID should be an integer, right? The employee ID should be an integer like 1, 2, 3, 4, 5, 6, 7, 8, 9, something like that, right? So based on what type of data should go inside employee ID, we define the type of the column here. So column name defined by what type of what type of values it will contain. So employee ID would be integers. So we have written integers. So name, then another column is name. So name is going to be a string. So we have given text here. Department is also going to be a string. So we have given text here. Let's say we had to add one more column, say address. What would be the data type then? Anybody in the chat can tell me, if we had another column, what would be the data type we will put? Text, text, text. Awesome. Varchar, correct. So varchar we can also put. So depending on what language it is. So text, varchar, that we can put. Awesome. Great. So this is what we are defining as the type of the column. Okay. You are seeing some additional things as well, like primary key, not null, and things like that, right? So these are nothing but some constraints on these columns. Okay. When I say constraints, it means that if there is some additional thing, additional rule that you want to put onto the column, then you can specify it after the data type. So we will learn later on what is primary key and a foreign key, but for now you can skip it. Okay, for now you can assume that this is doing something extra. This is doing something extra on this column. We will discuss that as this was part of our agenda, what are primary and foreign keys. So we will come to that on a later point of time. Okay. Not null means that, not null as the name suggests, that the data should not be null. There should be some value present in this. Okay. So if you have written not null, it means that the data should be present for every row. If it is not there, the table will complain. Okay. The SQL will complain that the column has additional constraint that name should never be null, and you are trying to put some null value here. Okay. So if you are creating a table and you know that there should always be data inside that column, then you can put not null in front of it after defining the type. Okay. So in address, I am not putting not null because some employee might not have given their address. Okay. So it is when you are designing the table, it is up to you whether you want to put these constraints or if you do not want to put these constraints. Okay. So yeah, so this is how a table is created. Then first task is done. Our first task is done, that we have created a table. Where we were, let me go back there. Okay, so this is done. We have created a table. What we need to do to create a table? We have to write the keywords create, then table, then name of table, and followed by columns, and data type. Okay, so this was the information that you needed to create a table. Now you have to insert some data inside the table, right? So to insert, you have to use the keyword insert. Okay, into is also a keyword, so you have to write insert into, then the name of the table in which you want to insert the data. Okay, so insert into, then table name. What is the table name? Employee. So you need to insert something into the employee table. Okay, after that there is one keyword called values. Okay, and this tells that what values do you want to add inside this table. Okay, see, if you see this syntax, you will say, sir, there is no column defined here, right? You have not mentioned employee ID, name, department. So how does the insert know which value to put in which column? So if you are not defining the order of columns in this insert query, then it will take the default order. Default order means that the way in which table was created. So basically, the first value will refer to employee ID, second value will refer to the name, and third value will refer to the department. Okay. So insert would automatically insert based on how the table was created. Okay. So if I had created the table like department here and name here, then clerk will go as department, sales will go as name. Okay. So it is advisable to add column names here, but if you already know how the table looks like, then you can use this syntax as well. Okay. So we are going with the simple syntax that insert into the name of the table and what values we need to insert into the table. The order should be same in which the table was created. Okay. Okay. So yeah, we have added the employee ID as 1, 2, 3, and for different users. So this represents one row. This insert statement represents one row. So our table looks something like this. So our table looks something like this. Our table name is employee. Our table name is employee, and under that we had three columns. Emp ID. We have three columns. Emp ID. Then we have name. Emp ID. Then we have name, and then we have department. Okay. Now this insert statement is creating one row. This is creating one row. So name is clerk and department is sales. Okay. So this is creating one row in the table. Okay. To insert another row, I have added another insert line. Okay. So this will create another row inside the table. Like 0002, the name is Dave, and department is say accounting or say IT. Okay. In this case, it is accounting. Let's write accounting only. Okay. So each insert statement is leading to addition of one row inside the table. Okay. So that's how your table is being created. Okay. So with these two steps in place, we have created a table and inserted the data. Okay. So now we are good with creating a table and inserting the data into the table. Any doubts in here? I'm going a little slow so that everybody is able to understand it properly. I see some questions. Automatic value insert himself in employee ID, sir. Yes, we can write the syntax to automatically insert the data, but we are not discussing that right away. What is not null constraint? Not null says that if you have added not null constraint, then means that name should never be null. Okay, you can't say that I am not inserting the name here. If you do that, the SQL compiler will complain that you said that there will be name always present, but you have not given anything. Okay. Sir, your video is on the text and not able to see it. Anybody else facing the same problem? Not sure. No doubt. How to insert a particular column? Then you have to give the column names here. If you give the column names here, let's say if you want to give employee ID only, then you give employee ID, then the values. Employee ID, the name, and then department. You can specify it like this as well. Okay. However, since this is a small table, we do not need to specify the particular column. The same problem you face on video. 1 second. which format we should save this file, I mean extension. I'm not sure. uh, let me zoom it a bit. If this, is it fine now? Are you able to see the screen still? Okay, how can we insert a row between two rows? In between, like there is no order defined, right? There is no order that this is the first row, second row, third row. So uh, so this no particular order per se. Like if you want to insert anything after it or before it, you can. Like there is no nothing like you have to insert it at a particular place. Okay. Primary key and unique key we will discuss later. How to insert more than one value with single query. Yes, you can. Sales go to the department column. Yes, sales will go to the department column. Yes. Okay. We will discuss this primary key and foreign key later on. Okay. Uh, because we want to finish all the topics in the today's session. Uh, First, we will discuss that, and if rest of the questions, like if rest we got more time, then we will discuss these additional questions that you have asked. Okay. All right. So moving now, we were saying that how we can query. So there are different uh, methods or uh, keywords available to do the query, but it depends on what type of query you want to do. Okay. So the basic or the first thing that you can query is you would like to see how your table looks like. That's the first basic thing you will want, right? So you have created the table, you have inserted the data there. Now the first and the foremost thing that you will ask is that, can I see like how my table looks like? Okay. So for that, you you can use the syntax select. Okay. Select means that you need to select some rows. Okay. What is the usage of select keyword? Select means that to select is used to fetch some slash all rows inside the table. Inside the table. Now the select is used to, since the select is used to find some or all rows inside the table, we can use select statement to see how our table looks, because these are nothing but rows inside the table. Okay. So we are writing select star. What do I mean by this star? This star or this asterisk means that all. This star means all, everything. Whenever you are using star, star means that you need to find each and everything. Okay, all. So select star means that select everything from. From keyword is from which table you want to get the data. From which table you want to get the data. So after from, we write the table name. Okay. So the table name in our case is employee. Okay. So we wrote the table name as employee. So if we run it, select star from employee, then let's see. So we run it. Okay. I had written these statements. So if you see this, your output is absolutely correct. It shows a table employee which has employee ID, the name, then department, and these are the values for each employee ID, name, and the department. So you see the employee ID as 1, name as clerk, department as sales. Similarly, employee ID is 2, name is Dave, accounting, and so on. Okay. So select star means that you need to select everything from employee table. Okay. But I mentioned, if you remember, I said select can fetch some rows also. Select can fetch some rows also. I might not want to select everything from the table, right? Then we can add some conditions. Then we can add some conditions based on which I need to fetch the data. Okay. Based on the conditions, I need to fetch the data. Okay. So for that, we will learn some more clause which we can add to the table to find the data. One more thing I would like to tell you here is you might not need to find all columns. So here I am writing the employee ID, the name, and the department. Suppose somebody says that no, I do not want all the information. Just give me the employee ID and the name. So here, what you can do is just write down the columns that you need. So you need employee ID and you need name. So if you specify the name of columns, then it will give you only that particular information. Okay. So if I try to run this, it is showing me now employee ID and name only. It is not showing me department because I said just give me the employee ID and the name, nothing else. Okay. Since I am asking only two columns, it is showing me two columns. If I ask for three columns, it will show me three columns. Okay. If I ask for a column that doesn't exist, then it will complain. So if I say, let's give me address, is address present in this table? No, right? So if I try to run this, then my compiler will complain. It is saying unknown column address. Okay. So you have to make sure that the column that you are asking for should also be present inside your table. Otherwise, your compiler will give an error. SQL compiler will say that this column does not exist. Okay. So first things first, we learned about select statement. Then the next thing is where clause. Okay. So select is we learned about select. Select is used to find the rows. Star means find all the columns. If you do not want to find all the columns, you can give particular column names as well. And there is one more thing that we can learn here is limit clause. Okay. What is the purpose of limit clauses? That as the name suggests, when you use keyword limit, it means that you are limiting something. You are limiting something to that extent. So suppose you have seen that speed limit 50, speed limit 50. You have seen these, or 60. You have seen that on highways, right? Not on highways, but at some places. So what does speed limit 50 mean? What does speed limit 50 means? That your speed should not exceed 50 kilometer per hour, right? Similarly, if you have limit clause here, it limits the number of rows that you are displaying. So suppose this table has 3 rows, right? But I want to see only one row. I want to see only one row, first row only. Then I will write limit 1. If I want to see only 2 rows, I will write limit 2. Okay, let me show you. Let me show you this. So if I'm writing limit 2, it will show only the first 2 rows that were inserted. So if I try to run this, it is showing me only the first 2 rows. Why? Because I have added that limit 2, only show me first 2 rows. Okay. Practical utility of adding a limit is when you want to see a particular row inside the table. You are working on a project and you want to see like how this table, how the data is shown in this table. So that is where you can use limit 1 to see one record, one row for a particular table. Okay. So this is highly used when you are working in an organization and want to see how a particular row looks like. Okay. Moving ahead, then we are learning about where clause. Okay. So suppose you have this table, and now somebody asks you, can you tell me information about the user Dev? Okay, I want to know what is the employee ID and what is the department. Okay, so question is, or the query is, what is the employee ID and department of user Dev? This is the query. So we know that to get the data from the table, we need to use select, because select is going to select some data from this table. And what we need to find? We need to find employee ID and department. So what I will write? I will not write star. I will say just find me employee ID and department. Just give me these two information from the employee table. Now I will have to add some condition. I have to add some condition here. Why I have to add some condition? Because the condition is given in the question that only for user Dave, I need to find the data. So what I'm saying is that select this information from employee table. We have to use a clause called where means that we have to give some condition after this. We have to give some condition after this, where name is equal to Dave. So it will select only those rows where this condition is true. Okay. So it will go to the first row. Is name equal to Dave? No. Is name equal to Dave? Yes. Is name equal to Dave? No. So it will print the data only for this particular row. And it will print only two information because we have asked only for employee ID and the department. Okay. So if I try to run this, if I try to, okay, this is one more thing I would like to tell you. To comment something, like when you add comments in Java or something, you add like these slashes, right? In SQL, you use these minus minus sign to make this line as a comment. Okay, this is added as a comment. This line will not execute. Okay, so if I try to run this, it is showing me some error. What happened? You have an error in your SQL syntax. Where? Let me run it again. Semicolon I have added. Not sure. Did we added anything else? Table name is correct only, right? Let me see. Okay, it is saying that. Okay. 1 second. That's the problem. Okay. Not sure why that comment was the problem. Okay. But if you add something like this, I don't think this is going to be a problem. Not sure what was the issue there. Yeah, I think with the newer comments, this particular online compiler is complaining. However, like you can see, like this is added here, so it's fine. Okay, I guess the space was missing. Yeah, 1 second. Yeah, now I think it's fine. It will run. I was missing the space after these minus minus sign, so that's why it was complaining. Okay, so when I run this query, select these columns where name equal to Dave, it is showing me the information for Dave only, that the ID of Dave is 2 and the department is accounting. Okay, so this where clause is used to add some conditions. Okay, and you can add multiple conditions also. So like name is equal to Dave, and suppose you need to find rows with name equal to Dave and department as sales. Okay, and department equals sales. So what would be the output here? How many rows this query should return? So you have to select all the rows where name equal to Dave and department equal to sales. Is there any row which satisfy both the conditions? Which satisfies both the conditions? And means this should be true and this should be true. So is there a row that satisfies both the conditions? No? Okay, let's see. It didn't output anything. Why? Because name was Dave, but the department is accounting. Okay, so this fails. Then this row, department is sales, but name is Clark. This will also not get printed. Department is sales, but name is Eva. So this will also fail. But if I write or here, it means that either this is true or this is true. So if name is Dave, we should print it, or the department is sales, we should also print it. So how many rows it will print? First row it will print or not? Yes or no? First row, will it print or not? No, right? Or yes? It will fetch in all condition. Okay, correct. It will fetch because row is sales, then Dave, then sales. So if I try to run this, it will print all of the three, because in the first and the third row, the department is sales, and in the second row, it will print because the name is Dave. Okay. So we can add as many conditions as we want after this where clause, uh, separated by and or. Okay. And if you want both of them to be true, or if you want any of them to be true, either this or this, any of them is true, then it will print it. Okay. 3 is the correct answer. I see a lot of folks mentioning 3, which is great. And thank you for your responses. So we learned about select, we learned about where. Now we will learn about order by. Okay, take a wild guess. What should order by will do? SQL, in SQL, the great thing is that the names are self-explanatory. You do not have to even like read about it. The names are self-explanatory. Like here, the name is where. Where means that where this condition could be satisfied, where this could be true, right? So you will very quickly learn about these things, like what each syntax or clause might be doing, right? Select is very intuitive that it is selecting something. Where is very intuitive that it is checking some condition. Similarly, order by, any guesses what it will do? Sort the records. Okay, sorting. Okay, close answers correct. Less than or greater than in between conditions, then apply by using order by. Sending sorting. Okay. So yeah, the order by, absolutely correct. Order by is doing what? Ordering the results by a certain way. Okay. So here what we are doing is we are okay. We were on that query. Sorry. So here what we are trying to do is, suppose we need to select the we need to show everything from the table. For everything we will add star, and we need to order by the uh, IDs in ascending order. Okay, we want to show the IDs in ascending order. Then I will say order by which column I want to sort, which column I want to sort, and how I want to sort. How means ascending order or descending order. Okay, which column I want to sort and which order, ascending order or descending order. So order by column is which column? Our column, this column is employee ID. Our column is employee ID. My bad. Our column is employee ID. So order by employee ID and ascending or descending. So if I want to sort by ascending, then ASC, sorting by descending, DSC. So if I run this, it is sorting the employee ID in ascending order 1, 2, 3. Okay. Similarly, if I had used desk here, if I had used desk here, it will sort in descending order 3 to 1. Is this, yeah, it is already in ascending order. That is true. So if I had like 2, 1, 3, then this will return 3 to 1, and ASC will return 1, 2, 3. Okay. Alrighty. So any doubts here? Till now, we have learned a great deal of things. Let me quickly summarize what we have learned. So first we learned the flow in which a request flows. The client makes a request, it goes to the server via an API, it goes to the database, because the data is stored actually somewhere, right? So that is where the database comes into the picture. The server queries the database via some querying language, which is SQL, and in and prepares the response and send it back to the client that this is your response that you were asking. Take the response and use it. And then we learned about relational database management system, that we have to find some relation among the data and show it in a format that can be used to query it. So we thought of adding the data inside a table. Okay, so we created tables. We create tables inside RDBMS. Then we learned that how to create a table. So we learned the queries like create and insert. So table should have columns defined by types and some constraints added to it. And then we added some insert statements to insert the data. Now, since we have the data populated properly, then we want to query. So with query, we know how to show all the records in the table, show specific columns in the table, like write down the column names here instead of star. Then we learned the where clause if we want to know particular information, that name is Dave, name is Eva, department is sales, or ID is 1. So any condition I can give, and multiple conditions I can also give by adding and slash or operators. And further, we have order by, which orders the data in ascending or descending order. Okay. Do not forget to add the column name. Okay. So column name, which column you want to sort it. You may want to sort by names. You may want to sort by departments. So the way in which you want to sort it, you give the column name, and then ascending or descending, you should tell ASC by ASC or DESC. Okay, we are good with that. Now we have learned where also, we have learned order by also. Then we have something like there is a like keyword also. Okay, uh, what do I mean by this? Inside the where condition, I will tell you what is this like clause. Where suppose I need to find all the names, that start with A. Okay. If I need to find all the names that start with A, then I can say name, where name like. Like means that the name is following this pattern. Like means that name is following this pattern. Where name like starting with A. Okay. Starting with A percentage. Okay. This A percentage means that the name will start with A. Rest of the characters could be anything. Rest of the characters could be anything. Okay. It should start with A. It should start with A, but rest of the characters could be anything. Okay. So if I run this, it will just print Eva. It is just printing Eva. Okay. Or if I say name starts with D, then it will print Dave. If I have to write name ends with E or name ends with K, what would be the change? Do you think? If I have to say name ends with D, sorry, K, what should I write? Start with, we know, like start character, percentage symbol. Take a wild guess. Percentage means skip everything, but start should be D. Okay, so percentage is skip everything, but last character should be K. So if I run this, let's see if it is printing the correct output. Correct. So it is printing Clark, ending with K only. No other is getting printed with K. And if I write percent, say A, what it will print? It is printing Clark, Dave, and Eva, because it says that any string with a in between, any string with a in between, print that. So Clark also contains a, Dave also contains a, Eva also contains a. So any string with a in between, we can do it by %%. Okay. All right. Moving further, there is one other clause used with where, which is called in. Okay. In is used to specify a list of items. Okay. So earlier, if you remember, we had written like where name is equal to Dave, right? Now suppose you need to find two names like Dave and Eva. Okay. So you can instead of equal to, you can use in. With in, you can give list of values. You can give list of values. So you can say where name in Dave and Eva. Basically, what we are saying here is when we have to give a couple of values, say 5 values we need to check, then we can give in clause here. So if I try to run this, it will print 2 rows, the names with Dave and Eva. So in clause is very useful when you have to give list of values. Okay. In clause is used when we have to give list of values. Okay. So is in clause clear to everybody? Is in clause clear to everybody? Give me a yes or no. What does E mean? Not sure what the question is. Clear? Okay. Awesome. Moving further, we have okay. 1 second. Clear? Okay. So moving further, we have strings. Okay. So how do you work with strings? So basically, if you want to find a particular substring, or if you want to convert your substring to uppercase or lowercase, there are some functions available with SQL. There are a lot of functions available with SQL, and depending on your use case, you can write those functions. So there are functions like upper, which will write your uh, column values in uppercase. So basically, if I want to write all these alphabets in uppercase, so I can write select upper and name. Okay. So it will print the name in uppercases. It will print the name in uppercases, Dave and Eva. Okay. So there are a lot of them actually. I have just taken one of them. There are a lot of them actually, and you do not need to remember each and every one. Okay, you do not have to repeat each and everything. Sorry, you do not have to learn each and everything. You can just search for the uh, utility which you want and then see the syntax for that. Okay, so there are a lot of functions, and it is not theoretically or practically possible to learn each and everything. So make sure that the very common ones you will remember over the period of time, but the other ones you may like just google it and find it. Okay. All right. Substring, I can tell you. So substring does what? Substring is fine as the name suggests. So if your string is like A, B, C, D, E, then if you need to find, say, this substring, B, C, D, then this function could be used. So substring will give a part of the string, a part of the string. Okay. So it will take two parameters. It will take two parameters. First is from where to start, and how many characters we need to take. So suppose if I need to start from B, I will give substring of 1, and if I need to find 2 more characters ahead of it, so 1 comma 2, which means that I will start from B and I need 2 characters ahead of it. Okay, so that is how substring works. There are a lot of functions that it has. So you can go to the documentation page of particular database management system that you are using. If you're using MySQL, go to MySQL. If you're using MS SQL, go to MS SQL documentation. See what are the functions available and how you can use them. There is a exhaustive list there, and you can use that to find your answers. Okay, with this, we have completed the basics of SQL. After this, we will be going with intermediate SQL. We will take a quick break for 5-7 minutes and then we will come back. How many folks want to take a break? If yes, we can take a break, else we will move ahead. So before we move to intermediate SQL, do you guys need a break? Just give me votes. Quick 5 minutes, 5-7 minutes break. Hey, keep moving. Can we learn view concept? View we are not covering today. Sorry. No, keep moving, keep moving, keep moving. Yes. Let's continue. Yes, no, yes, no. Sir, when sir will we get certificate? Yes, Ritika, you will get certificate at the end of the session. Break, break, break. Okay. There are like 50-50 responses for break and no break. Let's take a quick break for 5 minutes and then let's meet again to study about intermediate SQL. So take 5 minutes break and we will meet back at 4:20. Let's meet again at 4:20, and then we can discuss. Okay. So meanwhile, I would like to tell you about what AccioJob is and how is AccioJob helping students like you to get great jobs in the IT industry and upskill yourself so that you can learn about everything that you need for programming interviews and what the industry needs. So to begin with, AccioJob is an edtech startup which is run by IIT Delhi Alumni, and the AccioJob is helping students to build a career in software development, and there are various training programs which are offered by AccioJob, which will help you to like learn the right skills, like uh, like what we are learning today. However, this is just like what we are learning today is just a small gist of it. There is an extensive course that is laid out by Accio, which helps students to learn everything from scratch. So basically, whether you need data structure and algorithms, whether you need to prepare some projects, whether it is mentorship, whether it is mock interviews, each and everything they are providing. So there are structured courses which are provided by them, and there are proven results where they have 300 plus partners which work with them, uh, and they have helped students to get a median salary of around 8.3 lakhs, where the highest package was goes to 41 lakhs. So they have those proven results, and you can utilize that knowledge to upskill yourself and get placed in great companies. Uh, so the partners where the students have been working are Amazon, Visa, MMT, Salesforce, and other companies. Where and these are top tech companies where you can build your career and grow as a great software engineer. If we talk about eligibility, anybody is who has a passion for learning and build a career in software development is open. I get this question a lot actually. When I talk about eligibility, I get this question a lot that, sir, I am from mechanical background, I am from aeronautical engineering background. I do not have a background even in like engineering. I have been working in entirely different sector. I was preparing for UPSC, but now uh, I want to move to software development. So that's the good thing, that there is no particular eligibility. It is open to all individuals, and no matter what like your background is, you are eligible to learn these things. And they have like top instructors which will help you to understand the complex programming concepts in a very easy way, lucid way. So that's great. And I have been working with Accio as a mock interview. I take mock interviews there, help students assess their preparation. So basically, I tell them like where they are lagging or where they are performing good, and how they should prepare next, so that they can land in great software companies. So based on what my experience has with previous companies, and based on the knowledge that I have, I help them to land into their dream companies. So that's a very very good part. Like you can have unlimited one-on-one mock interviews, and you get that knowledge. Okay. And if you want to try it out, uh, there is a free pre-course also that you can try it out, and get in touch with the team. So see the session for yourself, understand whether it is working for you or not. Okay. Fees beyond imagination and expectations. Okay. uh, you can talk to the team. I think any investment on education is a good investment. However, if you want to try out the free pre-course. Fees high. Okay. So I get this question also, like how much amount is the right amount. Like there is not a number that you should think of, right? When you are upskilling yourself, the money is not a concern there. I feel that uh, uh, you must be uh, worried about learning, right? Money is going to follow. So that is not a problem. When you get placed at companies, you are going to get a decent compensation. So I think you should worry more about upskilling yourself, and money will follow. And yeah, as you can have free pre-course, you can see for yourself whether it works out for you or not. And this is and you can analyze for yourself. Don't take my word. Analyze for yourself whether it works out for you or not. Alrighty. That's what, sir, in AccioJob program, which one is good, sampling or pioneer? You may reach out to team to identify like which job program is suitable for you. And first go through the pre-course, understand where like uh, is it meeting your expectations or not. And then there will be a dedicated person from AccioJob who will help you to understand like which program works for you. Okay. All right. Let's take 2 more minutes break. I will be back after 2 minutes. Just taking a quick break, and then we will proceed. Okay. All right, I'm back now, and yeah, now we can start discussing further. I hope everybody's with me. Give me a yes or no if everybody's there. Anita, don't worry about the certificate. You will definitely get it at the end by the link that will be shared with you. I think let's focus on learning. You will definitely get the certificate at the end. Okay. All right. So I was saying that since we are done with the basic SQL, we learned about select, we learned about where clause, we learned about like, we learned about in. Now we need to learn about intermediate SQL concepts. Okay. So we will learn how we can aggregate the data. Okay. We will learn about how we aggregate the data. Aggregate means we want to find what are the if we join these, if we join the data, what we will get. Okay. So we will learn. Uh, so there are some operations that are available for aggregation, that you can find the sum of values inside a particular column. So suppose there is an employee table, and there is a salary column. Okay, there is an employee table and there is a salary column. Salary is say like 10K for one employee, 20K for another employee, 30K for another employee, 40K for another employee, and 50K for another employee. So what is, suppose I want to know total salary which everybody, like combining the salary of every person that is working in the organization, what is the total salary that is paid out? So total salary is 50 plus 40, which is 90, 90 plus 30, 120, 120 plus 20, 140, plus 10, 150. So total salary is 150K. Okay. So if I need to find the sum of the salaries, okay, then we can use these aggregations logic like sum. If we need to find the average of the salaries, then we can use the keyword average. If I need to find the minimum of these salaries, so out of these, what is the minimum? 10K, right? 10,000 is the minimum salary. So I can use the keyword minimum. If I need to find the maximum salary, which is 50K, I can use the word maximum. Okay. So, but these aggregations will be on a particular column. These aggregations will be on a particular column. Like there will be other columns also, right? Like there would be name of the employee, salary of the employee, address of the employee, ID of the employee, right? So I have to aggregate based on some column. So in our case, salary is the column on which I need to find the sum or the average or the minimum or the maximum. Okay. So based on that, we can find, based on that particular column, we can find all these things: sum, average, min, and max. So group by is used to define that particular column. That by which column you want to group it by. Okay. So here it is saying that okay, this is some different database. Let's add, let's say I need to find, let's add salary also. Okay, since we have employee table, we can add salary column. Salary is an integer. Salary is an integer, and let's say salary is also not null. Salary is also not null. Okay. And let's define a type also. Let's define a type also. Type is like these are like group 1 folks or group 2 folks. Okay. So type is also an integer. Like in when you are talking about government officials, like there are government officials which are grade 1, then grade 2, then grade 3. Or instead of type, let's add grade as the column name. Which grade they are falling in. Okay. That is also say Not now. Okay. Now let's add the data here. So say the salary of this person was 100, salary of this person was 200, salary of this person is 300. Okay. So if I need to find, say, max salary of a person, okay, or max salary from the table, without the group by, I can also do that. Without group by, I can also do that. So I will write select max and the column name, which column we need to find the maximum out of it. Okay. So if I need to find the max salary, so what I can do is select max salary from employee, and it will give you the maximum salary within this table. So if I run this, column count doesn't match. Oh, sorry, I didn't mention grade. So suppose these two people are grade 1 officers and this is a grade 2 officer. Okay. See, the maximum salary here is 300, right? So it is printing the maximum salary here. Similarly, if I need to find the minimum salary, then I can do that also. Minimum salary is 100, which is correct. Now I need to find the sum of salary. Find the sum of salary. If I find the sum of salary, what it will give? Let's see. It gives us 600. Okay. Why? Because 300 plus 200 plus 100 is 600. But if I need to find the column based on which I need to find the sum, say group by grade. Okay. So basically these officers, or not officers, these employees which have grade 1 get a total salary of 300, and grade 2 officer, let's make the salary as 500, just to see the difference. So grade 1 officers are getting a combined salary of 200 plus 100, which is 300, and grade 2 officers are getting a combined salary of 500 only. So if I try to run this, it is saying 300 and 500. Okay, let's print the grade also. Grade and sum. Now if you see, for grade 1 officers, the total salary is 300. For grade 2 officers, some total salary is 500. Let me repeat it once again, what I was trying to say. So these sum, average, min and max, these are the aggregation functions that you can use, and defined by on which column you want to do it. Grouping by is used on the particular column if you want to segregate the data. So basically, if you want to know that these grade officers or employees are getting combined salary of what is the combined salary of all of them, then you can group by a particular type or group by that particular column, and this sum will find all the summation. It will go to each row, fetch first whether what is the grade. Okay, first find all the rows to a particular grade and then does the summation on top of it. So similarly, it find all the rows with grade 2 and do the summation of all of it. Suppose we had another value like this, and the name was, say, meat sales, the salary was 200 and grade is 2, then your answer will be what? If I run this query now, what would be my answer? I am selecting grade and the sum of salary and grouping by the grade. So it is going to group by two grades. One grade is 1 and another grade is 2. So it will give us two rows. One row will contain the sum of all the rows with grade as 1. Another row will contain all the rows sum, which has the grade 2. So, okay, two folks have given the correct answers, 300 and 700. Absolutely correct. So, group by grade. Grade is 1. So, 200 plus 100 is 300. And grade is 2. So, sum is 500 plus 200, which is 700. So, let's see if it is giving the correct output or not. Yes, it is giving. So, 1 with 300, grade 2 will give us 700. Okay. I can also group by, so suppose find, question was find total salary of employees working in sales department. From this small table, we can say that there are 3 people who are working in sales and their salary is 500 plus 100, 600, 600 plus 200, 800. But what would be the query here? We have to find the sum of salary. That is true. We have to find the sum of salary. And we need to find the employees who are working in sales department. Only those salaries we have to take the sum. Only those salaries we have to take the sum. So what will get changed here? Should we group by grade or should we group by something else? Should we group by grade or should we group by some other column? We want to find sales department. Group by sales or group by department. We have to give the column name here. We can't give value here. We have to give the column name only. If I group by department, what would happen? If I group by department, what could happen? There are 2 departments, right? There is sales department, there is accounting department. So there will be 2 rows, one row with sum of sales and another row with sum of accounts. So if I run this, so it is giving me, okay, I have to print department also so that I can know which department I am talking about. So if I run this, sales have a total salary of 800 and accounting has a total salary of 200. Okay. Both the department will be considered. You can skip, you can ask like, you can insert a where clause to remove accounting, or where you can write where department is equal to sales the department equal to sales and group by department. If you run this, you will get only the sales department. Okay, so you can add a where clause if you just want sales. Okay. Now, one more thing I would like to tell you here is, if you see the output, it is showing department and sum of salary. Can we give a better name to it? Like, we know that this is total salary of all the folks working in the sale department. So instead of having this name as sum of salary, can we give it a better name? Yes, we can. For that, in SQL, we use the keyword as. As means that we want to show the name as something else. So like here, we want to show the name as total salary. Total salary. So if I run this, the name of my column will become total salary, which is much better than the previous one. Okay. So it is going to give us as a alias or a other name. Instead of writing some salary, I can give some meaningful name so that someone reading my query is going to understand what this column is going to return. Okay. So somebody reading this query is now able to get, okay, this column is giving the total salary. Okay. So let me summarize it again. What we learned in aggregation. We have multiple functions. Some we can also find average also. Okay. Similarly, we can find average salary also. Average is nothing but total sum divided by rows. So here, sales people, how many sales people were there? 500, 200, 100. So 3 rows were there. How do we compute this? There were 3 rows and total was 800. So 800 divided by 3 is 266 something, right? So that is what the output is. So it gets the average by adding the sum divided by total number of rows. Okay, is that clear to everybody? Yeah, before we move further, let me summarize what we learned. So we can get the aggregation by using sum or average or min or max by applying it on the particular column that we want to group, and we use the group by to club those rows. So if we want to club only those rows which have like grade as 2, then it will select the rows first which have the grade as 2 and then do the sum. It will select the rows which have the grade as 1 and then do the sum. Okay, similarly it will select all those rows. Suppose I want to find by sales, it will select the rows first it will select rows like sales is there, sales is there, sales is there. Now sum these 3 and put the sales and put the salaries. Then accounting is only one row, so it will go to accounting, put the sum there. So group by is doing what? First selecting the rows and then doing the operation, whether it is sum or it is average or max or min. Is that super clear to everybody? Give me a yes or no. Is this clear? Give me a yes or no, folks. Sum, min, max, average, and group by. We will do a very popular question and very much asked question in history of interviews, because this tests a lot of concepts that you have learned. Yes, clear, yes. Anybody with no or any doubt? Can we use department as something else too? Yes, we can. So if you want to give department as say department, you can write that. So it will give as department now. Okay. So you can use you can rename any column if you want. Truncate and delete one's example, sir. Okay, we will come to that. So truncate is going to delete all the rows in the table, and drop is going to delete all the rows as well as whatever indexes or whatever the table definition was, it will delete that. So both are going to delete the contents of the table. Drop and truncate both are going to delete the contents of the table. Drop is going to delete the metadata also. Truncate is going to delete all the rows. So if I want to make this table empty, if I have reinserted all these rows and I want to make this table empty, then what I will do, I will write truncate table name. Okay, so if I write truncate table employee, it will remove whatever everything was present. Okay. Okay. Having. Achha, you are asking having keyword. Yeah, having keyword is also used as like group by, but that is not currently in the scope of this session. So because we will be discussing some more important concepts. Okay. So yeah, the current question is, if I need to find the second largest salary, for example, in this database, okay, I removed this. Let me add salary again. So salary is another column which is integer, and this is not null. Let me add the salaries also. 100, 200, 300. Suppose if we need to find the second largest salary, how can I find that? Let's try to think. We can find the max salary very easily, right? We can write max salary. We can write max salary and it will give us the max salary, right? 300 it is giving. But I need to find the second largest one, not the first largest. I want to introduce two concepts here. That's why I took this question. So, what do you guys think? Use limit. Very good, Rakshit. Where salary is greater than 2. That should not work because salary is being compared with a number. Okay, so that will not work. Sir, please provide your notes, sir. Yes, I will. Order by desk and limit 2. Okay, great answer, but uh, it will give two values. It will give two values. Yeah, that is one answer actually. So the folks, if you remember, we have learned about limit keyword, right? We have learned about limit keyword. So if I use the limit keyword here, what I will do, I will be finding limit means that get me the top n rows. So if I write limit 2, it will give me top 2 rows. It will give me top 2 rows. But are the top 2 rows having the maximum values? No. So first we will sort them. We will order by descending. First we will order them. Okay. If I order them in descending order, what we will get? 300, 200, 100. Okay, one second. I made any error? Okay. So what we are doing, first we are trying to list it. You have an error in your syntax. Where I have the error? Hmm. Okay, I didn't give the column name. Yeah, so salary is written in descending order here, but I need to find the second largest. So if I write limit 2, then it will give me the top 2 salaries. The first one will be the largest and second one will be the smallest. But here I want, okay, good answer, offset 1. We can use this keyword. Good answer. We can use this keyword offset. Offset means to move by a particular value. If I move by one value, I will just print 200. So if I move by one index further, I will just get 200. So that is one way of writing it. But instead of that, I was expecting something else. What I can do is, this will give me top 2 rows, correct? This will give me top 2 rows. What if I write another query? And so like I select salary from this logic. And let's name this as employee order by salary desk limit 1. Let's first see if it gives the correct output. Okay, wait. It should give us the second largest. Wait, limit 2. Sorry. So first it will give me 300 and 200. Then I'm sorting by ascending, which is making it 200 and 300, and then it will give me 200. Okay, yeah, that should work, I guess. Did I make some error? Folks, give me 1 second. Oh, limit I have written, but no limit given. One second. Yeah. So what I'm doing here is, by this query, by this particular query, I am giving the top two salaries. I am giving the top two salaries, first being the highest one, second being the second highest one. So by this particular query, I am getting, so whatever I have written at line number 17, I am getting the top two salaries, 300 and 200. Now I write this query inside another select statement. So what I am saying that select salary from this output. Select salary from this output. Okay, we are selecting these both of two. But I say that you select both these two. Very good. But after that, order them again. Order them again in ascending order. If I order them again in ascending order, then 200 will come here and 300 will come here, and then it will give me and print the first one, so 200 will be printed first. Okay, but if will it work if the salaries were more than, there is one issue here, will it work if the salaries were like 100, 200, 300, 400, 500? Will it still give the correct answer? Will it still give the correct answer if these were the salaries? Let's see. Okay, let's see. You do not, whenever any question is asked in an interview also, you do not have to give the answer then and there. You have to first think whether our query is performing in the same way or not. Okay, and then think if it is will give the correct output or not. Before running the query, think by yourself. Okay, so let's add some more employees. Let's add some more employees here to test it out. Say meet eat, let's give 2 employees. Department, let's keep sales only. 400 and 500. Our answer should be 400, right? So first we are selecting salary. First this query will run. That select salary from employee, order by salary in descending order. So first it will print 500, then 400, then 300, then 200, and then 100, right? Limit of 2 will print only first 2. Rest of them will be skipped. Now I am selecting salary from the output of this query. So both of them will come. But I am saying that order by, so this is the salary. I am saying order it again. In what form? Ascending order. So 400 will come here, 500 will come here. And limit 1 will keep only first row. It will discard the second row. Limit 1 means first row only. Limit 2 means first 2 rows only. So it will give the output as 400. Now we have validated. Now let's run it. Now what happened? Did I miss something again? Okay. Please change ID. Okay, because this is a primary key. So okay, duplicates there. Yeah, so we get the largest salary as 400. Okay, there was one question. What is as means? It is just an alias. That we are saying. You can write anything here. You can write here A, B, C, D, X, Y, Z. It will still give you the correct answer. It will still give you 400. Why this is working? Because this is just a name for the output. Okay, from the output that we have considered the table name as this. Okay, so you can give anything here. You can give any name here. Any name you can give here. Okay, so but since it was employee table, so I gave the name as employee. Okay, so this was one way of doing it. But this introduces a very important concept. The concept is that you can write sub queries. This inner query gets executed first and the outer queries get executed later. Okay. This similar concept we can use without using limit also. Like select max salary, select max salary from employee, select max salary from employee. Okay, so this will print. So okay, let me comment it out first. If I run select max salary from employee, it will give us 500, right? But we want 400. So if I write another query, select salary from employee where salary is less than this, what it will print? What it will print? Oh, I see the answers in the chat, but let's try to understand it. Okay, let's try to understand it. So max salary here, this inner expression will evaluate to 500. The max salary here is 500. So if I try to understand this, this will come as like salary is where salary is less than 500. Okay. So if I write max salary here, what will the program become? It will say that find the salary which is, so okay, one second, let's not even write max salary. So this query becomes like this. This is super clear to everybody, right? Because this evaluates to 500. So our query becomes select salary from employee where salary is less than 500. Let's see what is the output. Okay, let's see what is the output of this. So output of these would be 4 rows. Output of this will be 4 rows, right? 100, 200, 300, and 400. If I find the max salary out of it, this will be the second largest salary, right? If I find the max out of it, this will become the second largest. So that's the only thing that we need to do. So we get the second largest salary as 400. Why it gave you the correct answer? Because 500 was the max. We printed all the values. We printed all the values which were lesser than 500. 100, 200, 300, 400. Out of these values, largest we know 500. Out of these, which is the maximum? 400. And 400 is the second largest. Is that super clear to everybody? There are other ways also. Yes, there are other ways to solve this. But the idea I want to give you is that subqueries are a great way of solving this. Okay. This is not clear. Okay, I will explain it again. So subqueries means that we write a query inside a query. We write a query inside a query. So here what we are trying to do is we wrote this query first. We wrote this query first. This query evaluates to maximum salary from the employee table. So maximum salary from the employee table was 500. And then I write select the maximum salary. Sorry, then I write select salary which is less than 500. So there were 4 salaries: 100, 200, 300, and 400. There were 4 salaries which were less than 500. Then I said find the maximum out of it. So if I find the maximum, this will become the second largest, because first largest we are already compared with. So out of them, any number of values that are there, the maximum will be the second largest. Second query example is best and easily comes to mind when it comes to this logic. Yes, that is why you should use subqueries. That is why you can use subqueries to easily think about it. Okay, this you may not be able to get in the first go, but there are multiple ways in which you can get this. And yeah, so here I am, let's try to understand it again. Okay, let's try to understand it again also. So what we are doing here, we are finding the salary from employee. For if you want to understand subqueries, no, write down the output yourself and then dry run it. So here we are selecting salary and ordering the salary by descending order. So if I order the salary by descending order, what I will get, this part, only this part. If I see, what I will get, 500, 400, 500, 400, 300, 200, and 100, right? Then I said limit of 2. So remove everything, just keep top 2. So this part is done. Now I said that select salary, order by ascending, So 400 comes first, 500 comes later. Keep the first one. So just keep the first one. Sir, difference between Oracle, SQL, NoSQL. Okay. Relational databases are those which store the data in form of tables. Others, there are NoSQL, as the name suggests, which stores the data in form of JSON. So, and use case depends. Okay, we will have some another session sometime to discuss more in more detail about this. Okay, I hope this question, this very important question, is super clear to everybody, which introduces the concept of subqueries, and it is also very like important interview question that has been asked. I was also asked this question, if I remember correctly, some way back when I started my career in software development. So yeah, you can utilize this information. Okay, alrighty. Now I want, before I move further, I want you to tell about joins. We are on top of time, but let's take another 15-20 minutes to understand about joins. And before we jump to that, I want to tell you about what is a primary key and what is a foreign key. Okay, this is a very important concept actually. So primary keys, you asked me this question in interview. Okay, all right, great. I hope now you know how to answer it. So next video, please, on NoSQL. Yeah, sure, we'll try. So I was discussing that what is a primary key. We had written it when we created this table, right? So primary key is a key, or is a column which contains, it is a column which contains unique values, and values are not null. So this is a unique identifier for any particular table. So if my table is employee, there should be one column which can identify each record uniquely. So if you see here, each employee has a different employee ID. Ideally, in a real world also, each employee should have their own ID, right? So we know that this ID is going to be unique for every particular user. For every particular user, it is going to be different. And that's why we made employee ID as the primary key. Okay, primary key is an identifier that this column contains unique values, and this should also not be null. If I try to keep same values, like here, if I try to keep 2 again, and I try to run this, my compiler will complain. It will say that I have added some error. Where? One second. Let me remove this. Okay. Should be good now. Text note. I had written something somewhere. Okay. This I have written. Comment. So yeah. it says duplicate entry 2 for the key employee dot primary, because this is a primary key, because the employee id is a primary key, it says duplicates are not allowed. Okay, so primary key should be a column which can identify all the records uniquely, and it should not be null. Okay, if I try to place null here, then it will also complain. Okay, then it will also complain. Now, one thing is that primary key is identifying uniquely, and it is not containing null. Another concept is a foreign key. Foreign key is nothing but suppose employee information is contained in this employee id, name, department, salary. This information is contained in one table. Okay, suppose there is another table, say employee performance, employee performance, and it contains only information related to performance of employee, like employee id, date of joining, rating of the employee. This relation between the table, this employee table and performance table, both have some relation between them. That is to the same employee ID. That this employee with one has a particular date of joining and a particular rating, some rating of that employee. So this relation between them. So this column here is the foreign key. Is the foreign key for the performance table. So primary key, the column employee ID here is the primary key, and it is referencing the employee performance. This column employee ID of employee performance table. What I mean by that is, suppose here is an employee 1. Okay, and there the employee 1 will have some information like employee id 1, date of joining say 1st January, and rating as 5. Okay, so basically this row is related to this row. Okay, what is the usefulness of this? Doing this? It means that there should not be any employee. Suppose I'm dumping some data in employee performance data. Okay, so it can be the case where data mismatch happens. So basically, there cannot be an employee which is not present here, which is not present in parent table. Okay, so parent table should have that entry, and it should be referenced in the other table. Okay, so please explain foreign key again. Voice is not clear. Foreign key means that there is this reference, this employee ID is being referenced in the other table, which means that it is referring to the same employee. So if there is an employee with an employee ID 5, but this employee 5 does not exist here, then it will say it is an invalid entry, because it will say it is an invalid entry because this employee does not exist here. In the main parent table, it is not existing. However, it is existing here, which is wrong. Is that clear to everybody? I can show you how a foreign key is created. So there is another example. So there is this person's table. Okay, there is a person ID, last name, first name, and age. And there is orders table that has order ID, order number, and person ID. So the person table has person ID as the primary key. The order table has person ID as the foreign key. Okay. So if you see, the IDs 1, 2, 3 are only being referenced here as 1, 2, 3 only. If I try to add another person ID as 4 here, if I try to add another person ID as 4 here, it will complain. Okay. So it will say that on the child table there is an invalid entry present. Okay. All right. So that was about primary key and foreign key. One more thing I would like to tell you was about indexes, but let's go ahead with joins now. Uh, or indexing, if I have to tell you in very short, I can tell you that when we are searching something, when we are searching something in a table, okay, so a table has some columns, right? Table has some columns. So table was employee, okay, and this employee table has some data like what's it, this employee table has some data like name, id, name, uh, salary, and other things, right? Now I am trying to search the name. I am trying to search the name in this employee table, okay. So suppose there are like 1 lakh rows. There are 1 lakh rows, and I need to search my name inside those rows. Then how I will search? Then how I will search if my name exists or not? What I have to do? There are 1 lakh rows, and I need to find my name there. What I need to do? Anybody? There are 1 lakh rows, and for each row I have to go in each row one by one. So first row is say ID 1, name is Pulkit, salary is 100. Okay, name is 2, name is Alex, salary is 200. So I have to go to each row. I have to go to each row, find my name whether it exists or not, up to 1 lakh rows. I have to go to every 1 lakh row, right? Every row, like all the rows I have to traverse, which will take a lot of time. And if the users are more, say 10 lakh users are there, then I have to go to 10 lakh rows, right? However, indexing solves this problem, okay. Indexing makes our search faster. Indexing makes our search faster. How? Very simple. What does indexing do is, indexing, let me show you, okay. So there was a table where the data of employees present. So employee id is there, name is there, rating is there, Aadhaar id is there, and 6 more columns were also there. So in total there were 10 columns present in total for this, and 6 more columns. Total 10 columns were there. So when I was fetching the data, so there were 10 columns, and say each column takes 1 byte. Each column takes 1 byte, and there are 1 lakh rows, and there are 1 lakh rows. So there are 1 lakh rows, or say 1,000 rows. Then it will take 1,000 bytes. It will take 1,000 bytes of memory to process. It will take 1,000 bytes of memory to process, because there are 100 rows. There are 100 rows. Each column will take 1 byte, and there are 10 columns. There are 10 columns. Each column is taking 1 byte and going through 100 rows. However, when we try to index something, then we create two things. One is the search key, and another is the data pointer. One is a search key, and another is a data pointer. What I mean by that is, so suppose, or I can show you directly. That this is the actual table where my data is stored. This is the actual table where my data is stored. In indexing, what I do is I create a search key based on which column I need to search. So like employee ID is there, I am searching based on employee ID. So like 1 is there, 2 is there, 3 is there, up to how many records are there. And there is a data pointer. Which points to the original row. That this 1 is pointing to this row. This 2 is pointing to this row. This 3 is pointing to this row. So basically what I have to do is I have to just find something in this search key. I have to just find this in search key and point to the row directly. So basically I need Earlier I was calling all the 10 columns. Earlier I was calling all the 10 columns. Now I just need two. One is the search key and another is the data point. So instead of 10, I am just using two. So this reduces our time from 1000 bytes to 200 bytes. The time, not the space. Overall search time is also decreased based on there are B plus trees used, but that is beyond the discussion scope of discussion for now. So while we are creating index on a column, we are actually reducing the complexity of searching. We are reducing the complexity of searching. That's why we are creating the indexes. Okay, this is a very, very high level idea about indexes. So don't worry about it. We can discuss later about this in detail. I just want to touch base on this, what indexing means. Okay. Finally, I will give you a very, very high level overview of joins because we are on top of time. So join means that when we want to join multiple tables. Okay. A simple example is suppose this is table 1, this is table 2. Table 1 has columns ID, name, roll number. This table 2 has address, ID. Okay. Now I need to find the ID, name and address of a particular student. I need to find the ID, name and address of a particular student. But the problem is address is in a different table and name is in a different table. So what I will do is I will join these two tables. Based on which column is common in them. So if you see clearly, ID column is present in both of them. ID is present here and ID is present here. So I will try to join them based on the ID and will fetch name from table 1 and address from table 2. So to make a join, what do you need? The column on which you want to join. Correct? So you want to join based on ID column, which is common in both of them, and select the columns that you need. So basically we need name from here and address from here. So we select name from table 1 and address from table 2 and join them based on the ID. Is the idea of joins clear to everybody? Give me a yes or no. Give me a yes or no. If the idea of joins is clear, why we need joins? Give me a yes or no. Yes. Can you give any example? Yeah. Actually, this was one example. So suppose this is student table, basic student details table, or student info table, and this table is student address table. This is the example, right? So basically we need to find the complete information of a student, the name of the student as well as address. The problem is that address is in a different table, name is in a different table. So we join these two tables based on ID, because if student 1 is present here, the student 1 address would be written here, right? So address would be say XYZ and ID would be 1. Right? So based on this ID, I will join these two columns, select the name of the student from this table and address from this table. Okay. So how do we add a join? There are multiple ways of doing a join. One is inner join, one is outer join, what is left join, what is right join. Okay, so what happens in a inner join and a outer join and a right join and a left join? So it is very simple. Inner join means that select only. So these two circles represent table 1 and table 2. So inner join tells us the common elements between the two tables. Left join will tell the common elements and all the values that are in the left side of the table, that are on the left side of the table. So basically, if there are two tables, student info and student address, suppose this is the left table, this is the left table, and this is the right table. So if there are any common records, if there are any common records between them, so suppose if they have the same common ID, it will print them. And it will print all the information which is not common in the left table also. So like it will print row 2 also in the left join. Similarly, right join will print the common elements and will print all the information that is on the right side. Similarly, full outer join prints common information, left side info as well as right side table info. Okay. There are more joins as well, but we are not discussing that. So inner join is, it returns all the rows where at least one match is there in both the tables. In left join, common matches are there, but apart from that, all the rows from the left table and the common ones between left and right are printed. In right, all the rows from the right table and common rows from the left table. In full join, all the rows where there is a match in one of the tables is printed. Okay, so how to do a join is very, very simple. If you have to write a join query, that is like very, very simple. What you have to do is you have to define the type of join. First, you have to define the type of join. So it is left join here. Select the type of join. That's the first thing. Then you have to tell the table name which we are trying to join. So specify the name of the table. Let's say it is table 1. Then on is a keyword. On is a keyword. You have to always write it. On is the keyword that you have to always write it. Then then you have to write the name of the table 1 that you had brought upon. So then you have to write the name of the table and the column that you want. So in our case, first table was student info. So we will write student info dot id should be joined with student address dot id. Student address dot id. Okay. So first give the table name dot column name and join it with, equal to means join it with second table, second column, like not second column, whatever column you want to join it with. Okay, let me show you one example very quickly for say inner join. Inner join is the one that is very that you will see at a lot of places. So suppose there are two tables, table 1 and table 2. Similarly, you can write left, right, any, just change the name here. If the name is left, just write left. If name is right, just write right. Okay. So here what is happening is select the columns that you need from the table, and this is the left table. The one that I write here after from, this is the left table. Okay, and inner join table 2 is the right table. The table 2 is the right table. Then write the column on which you have to make the join. So table 1, column of the table 1, table 2, column of the table 2. For example, there is a orders table and there is a customers table. Okay, there is an orders table and there is a customers table. I want to join them based on the customer ID. I want to join them based on the customer ID. So I will write that select what column we need. Okay, we need order ID. We need order ID from orders table and customer name from customers table. We need this column from orders table, order ID from orders table, and customer name from customers table. So we write select order ID from orders table customer name from customers table, and then we will write the left table and the right table. Left table is orders, right table is customers. Define the type of join, it is an inner join. Then write the logic after on statement, write the logic on which you want to join them. So orders table has customer id, customer table has also customer id. So if you join them, you will get order id from orders table and customer name from customers table. Okay. In case of a left join, it is similar to what we have written here. It is similar to what we have written here. Only what is getting changed, instead of inner join, we have written left join. That is the only thing that is changing. Same way you are doing the join, same way you are selecting the column names. Sorry. Same way you are selecting the column names. This from table, customers table is the left table, orders table is the right table. Okay. This you have to remember, that when you are writing this, select column names from this. So this table is the left table. After left join or after the join, whichever table name you write will become the right table. So this is the left table, this is the right table. Okay. So if I run this, let me show you. If I run this, it is bringing customer name from first table, order ID from the second table or the right table. Okay. So it is taking two things, and both the tables were different. Both the tables were different. Customers was a different table, orders was a different table. So that was a very high level overview of what joins are. So joins are needed when one column is in one table, another column is in another table, and we need to merge. We need to not merge, we need to get the data from both the tables. Alrighty. So let's summarize what we have learned and then we will wrap the session. So what is SQL? SQL is just a language to query the database. Why do we need to learn SQL? Because the server, when queries the database, needs some way to interact with the database, how it needs to find the data. So that query we have to give to the SQL, we have to write in SQL to give to the database, and database will give us the information which will be processed by the server and given back to the client. Some common operations we learned about select, we learned about insert, we learned about where clause, we learned about in clause, like clause, and we learned about aggregate functions like sum, min, max, average, and group by. We learned that based on the type of the column, we can group those particular columns. We also learned about subqueries, like find the second largest query, third largest query, like that. We learned about joins, which is very important when one column is in one table and another column is in another table. We learned about primary and foreign keys, because primary keys, what is primary key? Unique values, column which contains unique values, not null values. Foreign key, this is a constraint. This is a constraint that so that invalid data does not get inside, right? Then we learned about indexes, and what is the importance of indexes? To make the search faster. We could not discuss that in detail, but we get a high level idea. That indexes are used to fasten up the search. Okay. So that's all from today's session. Again, I would like to know the feedback for the session in the comments, and any doubts or questions are welcome. Any doubts or questions are welcome. About Accio, if you want to know something, our team is here. They can answer your doubts, or if I can help you with the doubts about any topics or about AccioJob, you can ask me. And there is a form that is also floated to receive your certificate. Please finish that to get your certificate. If you can give a rating also along with the feedback, that will be great. And a rating out of 5, if you can give, that will help me improve as a mentor. So could you share the notes? I will try to share the notes. I will just get in touch with the team if there is a way to circulate that to your mail IDs. We'll try to share the notes. Okay. Uh, I can see. Thank you everyone for sharing your valuable feedback, and thank you everybody for joining in. Nice session. Thank you. Got the certificate. Awesome. Thank you for joining in. Learned a lot. Great. Awesome. Awesome, folks. Thank you again. Wrapping up the session. Hope you have a great Sunday. Bye bye.